just want to show you another way of looking at this question here. Maybe once you've gotten a hang of what we're doing, you can even take a shortcut if you like. So I'm going to work this question a different way, and let's see if we'll get the same answer. So I'm going to break it down into 3 components again. So you have the 4th root of 81, and then you have the 4th root of x to the 12, and then you have the 4th root of y to the 16. Okay, so again, for this one, same approach. Ask yourself what number times itself 4 times to give you 81. So you have 3 times 3 times 3 times 3. So this will give you 3. Okay. Now for this one here, we're going to write it as x to the 12 over 4. Okay. So the exponent goes on top, the 4th root comes on the bottom as the denominator, and then you have y to the 16 over 4. Okay, looks a lot cleaner than the previous way to solve this. So here you have 3 to the 12 divided by 4 is 3. 16 divided by 4 is 4. So simply put, we have 3x to the 3rd, y to the 4th. Okay, so choose whichever way you feel comfortable doing, and let's live with it. Okay. Let's look at another one here. Again, use whichever approach you feel is easiest, and see if you can simplify this here. We're going to have the 3rd root of 27x to the 8th, y to the 9th, z to the 11th. What would you get? We'll do it a long way here. Okay, I'm going to have the 3rd root of, okay, now because our magic number is a 3, I'm going to see if we can get things to the 3rd power. So 3 times 3 is 9, 9 times 3 is 27. So I'm going to go with a 3 to the 3rd. And then you have x to the 8. So we'll go 2 times 3 is 6. And then you need 2 more to make 8. Okay? So again, 2 times 3 is 6, plus 2 is 8. I'm trying to get things to the 3rd power here. That's why it shows the 2 on the inside. Now, for the y term, trying to get 9, so 3 times 3 is 9. So this could work here. Now for the z, you have z to the, you're trying to get 11, so 3 times what is it? Close to 11. 3 times 3 is 9, so we'll go 3 to the 3rd, and then you need z to the 2nd to make 11. Okay? All of this is in the 3rd root. Tedious work again, but just got to watch the exponents here. So you can write this as 3 to the 3rd over 3. Okay, so 3 is the base. To the 3rd over 3. You have x squared to the third over 3. And then you have just x squared over 3, so x to the 2/3, and then you have y to the 3rd. I'm writing a lot of these numbers so that you can see exactly what's going on. Okay, so once you get comfortable with this, you can just don't write the 3 over 3 and just say it's a 1 and call it a day. But for now, let's write down everything we can. So here we have z to the 3rd and then 3 over 3. And then last we got z to the 2 over 3. Okay, now we can cancel things out. Okay, so it becomes a 1. You have 3 over 3 becomes a 1. Again, 3 over 3 becomes a 1. So ultimately you have 3x squared. Now here we're going to write this as the cube root of x squared, like that. Remember the denominator goes into become the little number there on the outside. And then here you have y to the 3rd, z to the 3rd, and like that you have z on the inside, and then the 3 in the numerator becomes, sorry, the 3 in the denominator becomes the little 3 here, and then the square root, the exponent 2. Okay, now commonly you're going to see the non-root term written together. So we'll say that this is 3x squared, y to the 3rd, z to the 3rd. Okay, take a deep breath, and then let's finish this off. You have the 3rd root of x to the 2nd, z to the 2nd. You can write it that way too. Okay, and let's call it a day.